So previous class was full of vectors, vector triple product, scalar triple product, है ना? Or condition in a plane, condition in space, condition in while two vectors are collinear. So today we will start with three-dimensional geometry, where very frequently I'll keep on using the concepts of vectors also. So what we will do in this chapter, equation of a line in 3D space, equation of a plane in 3D geometry, angle between two lines, angle between two planes, and between a line and a plane. Along with that, we will also talk about distance formula, section formula, and direction ratios and direction cosines of a line. All right. So this, I assume, so this distance formula, section formula, you have already covered in your 11th class. Direction ratios and direction cosines also you have done in your 11th, 12th class. And equation of line is also covered in 12th class. All right. Now equation of plane, angle between line and plane, this will be something new for you. So our main concern will be over these topics. So very quickly, I will cover some basic things about the coordinate space in 3D. Now, three mutually perpendicular lines in space which divide the space into 8 parts are called coordinate axes. And these 8 parts are called 8 octets. Alright, these 8 parts are called 8 octets. Now, the coordinates of a point are the distance from origin to the fit of perpendicular from point on the respective coordinate axis. Simple point to understand. Now, any point on the x-axis will be having y and z coordinate 0. Any point on y-axis will be having x and z coordinate 0. And any point on z-axis will be having x and y coordinate as 0. Got it? Now, distance between 2 points. The distance between 2 points a x1, y1, z1 and b x2, y2, z2 is AB. That is under root of x1 minus x2 whole square plus y1 minus y2 whole square plus z1 minus z2 whole square. This x1 minus x2 whole square plus y1 minus y2 whole square was already there in your 2D geometry. Now here, and another thing, that z1 minus z2 whole square also came into the picture. Am I clear? So, distance formula in 3D. All right. Now come to section formula. Exactly same that we have covered in 2D. Now the z coordinate also came into picture. So it is mx2 plus nx1 upon m plus n. Y is my2 plus ny1 upon m plus n. And z is mz2 plus nz1 upon m plus n. All right. Now, if this division is external, not internal, then this x is mx2 minus nx1 upon m minus n, my2 minus ny1 upon m minus n, and mz2 minus mz1 upon m minus n. Am I clear? Definitely coordinates of midpoint of x1, y1, z1 and x2, y2, z2 is x1 plus x2 by 2, y1 plus y2 by 2 and z1 plus z2 by 2. That means when the ratio is 1:1. All right, these are simple things. Now, if a x1, y1, z1 and b x2, y2, z2 and c x3, y3, z3 are vertices of a triangle, then centroid of triangle is x1 plus x2 by plus x3 by 3, y1 plus y2 plus y3 by 3, along with z1 plus z2 plus z3 upon 3. Am I clear? Now, area of triangle ABC. See, they have given something like a formula for the area of triangle. But you don't have to remember it. Since I told you, if this is a triangle, its vertices are A, x1, y1, z1, B, x2, y2, z2, C, x3, y3, z3. Now, if I want to write AB vector will be x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. AC is x3 minus x1 I cap, y3 minus y1 j cap, z3 minus z1 k cap. So the area will be what? What I told you, half of magnitude of AB cross AC. You remember that? So that is half of what will be AB cross AC? It is I cap, j cap, k cap, x2 minus x1, y2 minus y1, z2 minus z1, x3 minus x1, y3 minus y1, z3 minus z1, and then mod of this. So this is going to be the area of this triangle. So you don't have to remember anything like the formula of this. All right. Now, if area of triangle goes 0, then these points are, if area of the triangle goes 0, these points are called collinear points, which is very much obvious. Yes or no? If area of this triangle will be 0, these points will be called collinear points. Now, you see, four non-coplanar points A, B, C, and D form a tetrahedron with vertex A, B, C, D and 6 edges. Now, how this tetrahedron is like this. So this is A, B, C, and D. This tetrahedron is a pyramid. See, this A will be say x1, y1, z1. B is x2, y2, z2. C is x3, y3, z3. And D is x4, y4, z4. So this ABCD is a tetrahedron with vertices as A x1, y1, z1, B x2, y2, z2, C x3, y3, z3, and D x4, y4, z4. All right. Now, two terms that we generally talk about, centroid of this tetrahedron. So centroid of the tetrahedron will be x1 plus x2 plus x3 plus x4 by 4. Similarly, y1 plus y2 plus y3 plus y4 upon 4. Similarly, z1 plus z2 plus z3 plus z4 upon 4. So it is x1 plus x2 plus x3 plus x4 by 4, y1 plus y2 plus y3 plus y4 upon 4, z1 plus z2 plus z3 plus z4 upon 4. Am I clear? Now, volume of the tetrahedron, I have already told you. Volume is what? Volume is box AB, AC, AD. Scalar triple product of AB, AC, and AD. Now, what is this AB? AB is x2 minus x1, y2 minus y1, z2 minus z1. What is AC? x3 minus x1, y3 minus y1, z3 minus z1. And what is AD? x4 minus x1, y4 minus y1, z4 minus z1. So this is already 1/6 of this. 1/6 of this. This is the volume of the tetrahedron. That is 1/6 of ABACAD. If ABACAD are the coterminous edges of a parallelepiped, then this 1/6 won't come. It is directly box of ABACAD. Got it? So the volume of tetrahedron is like this. Am I clear? Now comes the very important point in the chapter, that is direction cosine and direction ratios. Now, what is direction cosine? Say we have a vector and this vector is making angle alpha, beta and gamma with the positive directions of x-axis, y-axis and z-axis. Alright. If a vector makes angle alpha, beta and gamma with the positive direction of x-axis, y-axis and z-axis respectively, then these alpha, beta, gamma are called, these alpha, beta and gamma are called direction angles. If there is a vector which is making angle alpha, beta and gamma with the positive direction of x-axis, y-axis and z-axis, then these alpha, beta, gamma are called direction angles. And these cos alpha, cos beta, cos gamma are called direction cosines. And these cos alpha, cos beta, cos gamma are called direction cosines. And they are denoted by LMN. This LMN is a very standard term for direction cosines. There's no substitute to it. Alright, so cos alpha, cos beta, cos gamma are what? Cos alpha, cos beta, cos gamma are what? Direction cosines. And they are denoted by L, M and N. Am I clear? Now, what does the direction cosine do? See, we have a vector A as A1 I cap plus A2 j cap plus A3 k cap. Got it? Let its direction angles be alpha, beta and gamma. Now cos alpha will be what? Vector A dot I cap upon magnitude A I cap. Cos alpha is what? A dot I cap. So that is A1 upon under root of A1 square plus A2 square plus A3 square. Cos beta is what? A2 upon under root of A1 square plus A2 square plus A3 square. And similarly, if you find cos gamma, it will be A3 upon under root of A1 square plus A2 square plus A3 square. Am I clear? So in that case, this cos square alpha plus cos square beta plus cos square gamma goes 1. Cos square alpha plus cos square beta plus cos square gamma goes 1. That means L square plus M square plus N square is 1. This is very standard notation for direction cosines. So if cos alpha, cos beta and cos gamma are direction cosines, then cos square alpha plus cos square beta plus cos square gamma is 1. Means L square plus M square plus N square is 1. Got it? Now, another term is direction ratios. Okay, what I just talked about is direction cosines. Then there comes direction ratios. Now, direction ratios are 3 numbers which are proportional to direction cosines. Getting my point? So it's not a unique value. Direction ratios are not something which is unique for a line or for a vector. They can vary. There are 3 numbers which are just proportional to direction cosines. Like if I say direction cosines are 1 by LMN, so direction ratios can be 2L, 2M, 2N, L by 2, M by 2, N by 2, or say under root 3L, under root 3M, under root 3N. It can be anything. Anything in the same proportion of direction ratios are called direction cosines. So if numbers ABC are proportional to LMN, if numbers ABC are proportional to LMN respectively, then ABC are called direction ratios. If numbers ABC are proportional to LMN respectively, then ABC are called direction ratios. Got it? So if ABC are direction ratios, LMN are direction cosines, so their proportion will be final and constant. Got it? Now, let's do a question. So the question is, okay, before doing that question, let's do one more 2 points. Line we will do in a while. See, direction cosines are unique, but direction ratios are not unique and can be infinite because they are just proportional to direction cosines. So direction cosines are unique, but direction ratios are not unique. Now, if ABC are direction ratios of a line and LMN are direction cosines of a line, then L is what? L is A upon under root of A square plus B square plus C square. M is what? Plus minus B upon under root of A square plus B square plus C square. And similarly, N is what? C upon under root of A square plus B square plus C square. Now let us say if you have any vector. If I have a vector A as A1 I cap plus A2 j cap plus A3 k cap. If you can convert this vector into a unit vector. So A cap will be what? A1 I cap plus A2 j cap plus A3 k cap upon under root of A1 square plus A2 square plus A3 square. Now see, for this vector A1, A2, A3 were direction ratios. For this vector A1, A2, A3 were direction ratios. But for the same vector, now if I convert it into a unit vector, this A1 upon under root of A1 square plus A2 square plus A3 square, A2 upon under root of A1 square plus A2 square plus A3 square, and A3 upon under root of A1 square plus A2 square plus A3 square is called what? Is called direction cosines. Because now you have converted it into a unit vector. So they are called direction cosines. All right. Now, direction cosine of a line which is equally inclined to the coordinate axis. Equally inclined means alpha, beta, gamma are same. So if alpha, beta, gamma are same, so cos alpha, cos beta, cos gamma are same. If they are same, that means L, M and are same. L is basically cos alpha. So if L square plus M square plus N square is always 1 and L equals to M equals to N. So 3L square is 1, so L goes plus 1 by root 3 plus minus. So similarly M goes and similarly N goes. Am I clear? Now, if LMN are direction cosines of a line, maximum value of LMN that can be done using AMGM, not too much of worth considering. Got it? Now, how do we find the angle between two vectors or lines? Angle between two lines with DCs as L1, M1, N1. DCs is direction cosine and L2, M2, N2. So angle between them cos theta will be L1, L2 plus M1, M2 plus N1, N2. Now in the denominator, you will have L1 square plus L2 square plus L3 square, which is 1. Also, you will have L2 square plus M2 square plus N2 square, which is also 1. Sorry, I think I made a mistake. In the denominator, you will have L1 square plus M1 square plus N1 square, which is 1, as well as L2 square plus M2 square plus N2 square, which is also 1. Now, if direction ratios are given, as A1, B1, C1 and A2, B2, C2. Now, what will be the angle between them is A1, A2 plus B1, B2 plus C1, C2 upon under root of A1 square plus A2 square plus A3 square into under root of B1 square plus B2 square plus B3 square. Got it? Simply like we do the angle between two vectors. Now write down a question. A line has direction cosines as L, M and Lmn and L plus delta L, M plus delta M, N plus delta N, delta N in its two adjacent positions. Adjacent means they are very near to each other. In its two adjacent positions. If delta L is angle between them, then prove that, sorry, delta theta, let's do it delta theta, delta I already used. Then prove that delta theta square is delta L square plus delta M square plus delta N square. Alright guys, you just attempt it. I'll be back in a moment. Give it a thought. Alright, everybody. Have you tried it? Anybody got the correct answer? Or somebody who have been able to prove it? Anybody? Madhukar? Sivamani, Madhukar, Priyadarshini, Bhagat. Have you been able to do it? See, first of all, they are saying L M N and L plus delta L, M plus delta M, N plus delta N are direction cosines in two adjacent positions. So whenever they use the word adjacent positions, means they are very close to each other. That means this delta theta is also approaching to 0. Delta L, delta M and delta N are also approaching to 0. So the conditions given to me is L square plus M square plus N square is 1. L plus delta L square M plus delta M square इधर ही आ जाओ. N plus delta N square is also 1. Now it is L square plus delta L square plus 2L delta L plus M square plus delta M square plus 2M delta M plus N square plus delta N square plus 2N delta N equals to 1. All right. Now L square, M square, N square is already given to me as 1.
F12, 10 concept.
So L delta L plus M delta M plus N delta N is going to be negative of delta L square plus delta M square plus delta N square whole divided by 2. All right. Now they're talking about the angle delta theta between these two vectors. They're talking about the angle delta theta between these two vectors. So what will be delta theta? Delta theta will be L into delta L. So cos of delta theta will be L delta L plus M delta M plus N delta N. Denominator में if you do even L square plus M square plus N square, that is 1. L plus delta L square plus M plus delta M, just a moment. Delta theta will be L into L plus delta L plus M into M plus delta M plus N into N plus delta N. Am I correct? Now, this cos delta theta can be written as 1 minus 2 sine square delta theta by 2 is L square plus M square plus N square plus L delta L plus M delta M plus N delta N. Am I correct? Now this L square plus M square plus N square is 1. It is cancelled by this one. Now they have mentioned in the question in its two adjacent positions. Means when the positions are very close to each other, this delta theta is almost 0. And if delta theta is close to 0, this sine delta theta by 2 will come out as delta theta by 2.
So 3-dimensional geometry है ना, straight lines वो नहीं है.
So delta theta by 2 whole square is, now this L delta L plus M delta M plus N delta N can be substituted from here. So minus of, so 2 outside here, delta L whole square plus delta M whole square plus delta N whole square whole divided by 2. All right, these minus minus goes plus, this entire 2 cancelled. So you get a result as delta theta square is delta L square plus delta M square plus delta N square. Got it? Have a look at it. Try to absorb. Bit of tough question, but very good. Have a look. So I think you must have got it, absorb it, written it. Now let's go forward. Now see, direction ratios of a line joining 2 points x1, y1, z1 and x2, y2, z2 are x2 minus x1, y2 minus y1, z2 minus z1. Why so? Now let us assume there is a line having passing through 2 points A, x1, y1, z1 and B, x2, y2, z2. Yes or no? So there is a line passing through 2 points A, x1, y1, z1 and B, x2, y2, z2. Now this vector AB can be written as x2 minus x1, y2 minus y1, z2 minus z1. That means direction ratios of this line AB are x2 minus x1, y2 minus y1, z2 minus z1. Agreed? So direction ratios of this vector AB are these. So line AB are also same. So direction ratios of this line are x2 minus x1, y2 minus y1, z2 minus z1. And now if I convert it into direction cosine, that means you have to divide, you have to make it a unit vector. That means you have to divide it by the magnitude of AB or magnitude of PQ, which initially they have given as PQ. So direction cosines will be x2 minus x1 upon PQ, y2 minus y1 upon PQ magnitude, and z2 minus z1 upon PQ magnitude. All right. Am I clear? Now, let us talk about a line. Line in space. Line in space. We will write the equation of line in both vector form as well as in 3D form. So first of all, let's talk about in vector form first. Equation of a line passing through a point P, that is x1, y1, z1 and parallel to a vector B. Equation of a line passing through point P, x1, y1, z1 and parallel to vector B. Let us call it, this is ai cap plus bj cap plus ck cap. Now see, let me call this point as A. Now if there is a point R on this line, like in 2D we have a point x comma y, here we have a point R. So we can say this R plus A is parallel to vector B. So if R minus A is parallel to B, so R minus A is lambda vector B. Yes or no? So R is A plus lambda vector B. R is A plus lambda vector B. This is the point through which this line is passing. This is the vector parallel to the line. So R is A plus lambda vector B. Am I correct? R is A plus lambda vector B. Now if I want to do it in 3D, got it? See, this lambda is a parameter. You keep on placing different values of lambda, you keep on getting different points on this line. Got it? You keep on getting different points on the line. So if this point R is xi cap plus yj cap plus zk cap. All right. So R minus A is lambda vector B. That means x minus x1 upon A is y minus y1 upon B is z minus z1 upon C. This is the equation of line. X minus x1 upon A is y minus y1 upon B is z minus z1 upon C. The points in the denominator, they are direction ratios. And these x1, y1, z1 are the points along which this line is line. Got it? So now if I see a line as x minus 2 by 3, y minus 3 by 2 is z minus 1 upon 4. That means line is passing through. Line is passing through 2, 3, 1 and having direction ratios as 3, 2, 4. Line is passing through 2, 3, 1. 2, 3, 1 is what? Where denominator, numerator gets 0. Line is passing through 2, 3, 1 and along 3, 2, 4. Now if I write another line, say 2x plus 1 upon 3 is 3y minus 1 upon 7 is z minus 2 upon 0. Say we have like this. Now you directly cannot find the point through which this line is passing. So for that, first of all, make the coefficient of x, y and z in the numerator as 1. First of all, find the coefficient of x, y, z in the numerator as 1. So divide both of them as by 2. So it will be x plus 1 by 2 upon 3 by 2. Y minus 1 by 3 upon 7 by 3. Z minus 2 upon 0. Another thing, denominator 0 in the denominator is not a vague thing here. Like in mathematics, denominator cannot be 0, but here it can be. That means this line is having no component along z-axis. Simply. So line is passing through which point? Passing through minus 1 by 2, comma 1 by 3, comma 2, and having direction ratios as 3 by 2, 7 by 3, comma 0. Am I clear? So line is passing through minus 1 by 2, comma 1 by 3, comma 2, and having direction ratios as 3 by 2, 7 by 3, and 0. Clear? Now, if you have a line in vector form, we can write it in 3D form because we know the point and direction ratios. If I have a line in 3D form, we can write it in the vector form. Got it? Now, simply like I have a line x minus 3 by 4, y plus 1 by 2 is z minus 1 upon 3. This is the 3D form. Vector form we can write it. Now, line is passing through 3 minus 1, 1. So 3i cap minus j cap plus k cap plus lambda times it is along 4, 2, 3. So 4i cap plus 2j cap plus 3k cap. Am I clear? Now, what if they ask you to find the equation of a line passing through two given points x1, y1, z1 and x2, y2, z2? First of all, let us say in vector form, this is point A and point B. So what you will do, you will assume a point R on it. So R minus A will be parallel to B minus A. So I can say R minus A is lambda times B minus A. So R is A plus lambda times B minus A. All right. R is A plus lambda times B minus A. If you want to write this line equation in 3D form, it will be x minus x1 upon x2 minus x1 is y minus y1 upon y2 minus y1 is z minus z1 upon z2 minus z1. This is the equation of this line in 3D form. Am I clear? Now, this is the written note for it. Equation of a line passing through a point A, that means passing through a point position vector vector A and parallel to vector B. All right. And parallel to vector B is R is A plus lambda vector B. R is A plus lambda vector B. Now, if coordinates of A, B, x1, y1, z1 and the direction ratios be A, B, C, then equation of line is x minus x1 upon A is y minus y1 upon B is z minus z1 upon C. Got it? Now, equation of line passing through two given points A, x1, y1, z1, b, x2, y2, z2 is x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. So it is x minus x1 upon x2 minus x1 is y minus y1 upon y2 minus y1 is z minus z1 upon z2 minus z1. Its vector form is a plus lambda times b minus a, that we have already talked. Got it? Now, let's do one question. Find the point of intersection of the point of intersection of two given lines x minus x1 upon 2 x minus 1 upon 2 y minus 2 by 3 z plus 1 upon minus 1 and x plus 2 upon minus 1 y plus 2 upon minus 3 is z minus 3 by 4. So how do we find the point of intersection of these two lines? So to get the point of intersection, let us assume this is lambda and this is mu. So assume one parametric point on each of the line. So on this line, point will be 2 lambda plus 1, 3 lambda plus 2 minus lambda minus 1. Just a moment, student. So, first of all, we'll assume a parametric point on the first line, that is 2 lambda plus 1, 3 lambda plus 2 and minus lambda minus 1. Now assume another parametric point on the second line, minus mu minus 2, minus 3 mu minus 2 and 4 mu minus 3, 4 mu plus 3. Got it? Now do one thing. See what will happen at the point of intersection. X coordinate will match, Y coordinate will match, Z coordinate will match. So that will be one single point on both the lines. So what you need to do, equate X coordinates. So 2 lambda plus 1 is minus mu minus 2. So mu minus 2 plus 2 lambda is minus 3. Now equate their Y coordinates. So 3 lambda plus 2 is minus 3 mu minus 2. So 3 lambda plus 3 mu is minus 4. Got it? Now solve these two equations for lambda and mu. Solve for lambda and mu. Like first equation is multiply by 3. So 3 mu plus 6 lambda equals to minus 9. This is 3 lambda plus 3 mu equals to minus 4. If I subtract both of them, I get 3 lambda as minus 5. So lambda as minus 5 upon 3. Now put this value of lambda to get the value of mu. So mu will be minus 3 and plus 10 by 3. I placed in the first equation. So it is 1 by 3. So you got lambda as minus 5 by 3, mu as 1 by 3. Now equate the z coordinates. That means lambda minus 1 is 4 mu plus 3. Now check if this lambda, that is minus 5 by 3, and mu, that is 1 by 3, are they satisfying this equation? So if this lambda and mu are satisfying this equation, that means line will be intersecting and we got the point of intersection. If this lambda and mu, they do not satisfy this equation, that means these two lines are actually not intersecting. So here in this case, if I see these values of lambda and mu, they do not satisfy this equation. So if they do not satisfy this equation, that means lines are not intersecting. Am I clear? Lines are not intersecting and they are not parallel. That is already visible to me. They have different direction ratios. So lines are not parallel, lines are not intersecting. Such lines are called skew lines. Such lines are called skew lines. And what do we figure out in skew lines? We find the shortest distance between these two skew lines. Got it? Now, see, if the direction ratios of two lines be A1, B1, C1 and A2, B2, C2, then angle between them is very much clear. We have already covered it. A1, A2 plus B1, B2 plus C1, C2 upon under root of A1 square plus B1 square plus C1 square into under root में A2 square plus B2 square plus C2 square. Now condition for lines to be parallel is A1 upon A2 is B1 upon B2 is C1 upon C2. Condition for lines to be perpendicular is what? This cos theta goes 0. That means A1 A2 plus B1 B2 plus C1 C2 is 0. Am I clear? So see, these two lines we have done, but if I try to find out the angle between these two lines, see, first line के direction ratios of first line are 2, 3, minus 1. 2, 3, minus 1. And direction ratios of second line are minus 1, minus 3, 4. So angle between them will be A1, A2, that is minus 2 plus B1, B2 minus 9 plus C1, C2 minus 4 upon under root of A1 square plus B1 square plus C1 square. So it is 4 plus 9 plus 1 under root of 1 plus 9 plus 16. So acute angle generally we try to talk about. So that will be 9 and 4, 13 and 2, 15 upon under root of root 14 and root 26. So theta is cos inverse of 15 upon 2 root 13 and 7, 90. Got it? So this is how we find the angle between two lines. Am I clear? So that would be all from me today. In our next class, we'll talk about the distance between skew lines and we'll jump to planes. All right. Till then, you keep on practicing your things. And in the meantime, just fill this simple form.